Hi, my name is Brandy, and today we are going to be talking about the predator-prey relationship and how they influence each other. We always learn that predators capture their prey and that the prey is helpless against their predators, but that's not exactly true. Prey have their own defense strategies that they use to avoid being eaten by predators. Some of these tactics include camouflage, which helps them hide from their attackers, armor to help defend themselves, or these beautifully crafted escape tactics that make it hard for predators to capture them. Today we are going to explore the different ways that prey avoid being eaten by predators using a fun little experiment. This experiment includes 3 separate simulations to demonstrate predators attacking their prey. The first simulation is to demonstrate camouflage, where you as the predator has to pick the prey out of its surroundings. The second simulation is demonstrating escape or like slippery behavior, where you have to capture the prey that has a good escape strategy. And the third simulation demonstrates trying to attack the prey that has armor as a defense. This first simulation is to represent camouflage, where you pick 10 peanuts out of the surrounding 50 coins and see how many you can get in the allotted 1-minute time. So in the second simulation, we are representing escape tactics or slippery behavior, where you have to pick out the prey from a tall glass without touching the glass using chopsticks. And doing this is a little bit difficult, especially if you don't know how to use chopsticks. And you have 1 minute to try and pick out as many prey from this glass as you can. This is Simulation 3, and in Simulation 3, the tokens have tape wrapped around them that represent armor, and then armor helps these prey avoid being captured. In this situation, 2 of the tokens are taped together, and then it's taped around 3 separate times to make it very difficult to try and attack the predators, or attack from the predators. After running these simulations, the easiest prey strategy to capture was in Simulation 1, representing camouflage. In this simulation, I as the predator was able to capture all 10 in the prey in the allotted time of the 1 minute for each of the 3 trials. The next hardest strategy was the escape tactic. I was able to capture most of the prey in the 1 minute trial, but it was harder and it took a lot longer for me to capture the prey in this situation than the camouflage. The hardest prey to capture by far was in Simulation 3, and this was representing armor defense. In this simulation, I was only able to capture 2 of the prey in each of the trials, making this tactic the most effective in this experiment. In this bar graph, the number of prey captured in each trial was averaged and then plotted. The highest number of captures was in Simulation 1 on the tray, and the hardest prey to capture was in Simulation 3 using the tape. Each of these tactics is something that is used by prey in the wild. For example, camouflage is used by a number of species to avoid predators. One species that uses camouflage as a way to avoid predators is the kangaroo. The kangaroo is a neutral brown color that blends in well with the brush, which is in the surrounding areas, and they hide among that brush in order to avoid being seen. An example of an escape tactic is one used by the fish-scaled gecko. When they are attacked, they shed all of their scales in order to reveal like a slippery skin below, and it makes it really hard for their predators to capture them because they are able to escape pretty easily. And finally, an example of armor that is used is one used by porcupines, and porcupines have these quills that can hurt the predators when they are attacking the porcupine. In some of these simulations, some of the prey escaped capture, but that doesn't necessarily mean that it was escaped or that they escaped by chance. In the wild, some prey may exhibit better qualities or better quality adaptations that aid in their escape from the predators. These better or worse adaptations are the driving force of evolution. When the prey have a better escape tactic or better armor, they are more likely to reproduce and pass on their genes so their offspring have better armor and tactics as well. In the case of the predator, over time it was a lot easier to capture the prey as I was practicing my strategy. And these tactics by predators, even used in the wild, I would assume become a lot easier when they use a strategy. And it's very similar as to what would happen in the wild. And then finally, one predator avoidance strategy that was not mentioned in the simulation, which is one of my favorite actually, is the warning coloration. And for example, there is a coloration type called Batesian mimicry, which is when a species that is not poisonous displays the coloration that mimics a poisonous species. One example of that would be the king snake, and the king snake has black, red, and orange coloration that goes down in stripes along its back. And this coloration is very similar to the poisonous coral snake, which has the same coloration and the same pattern as the king snake. And these king snakes avoid being eaten because they are warning predators that they might be poisonous. And under these strategies, the predators of the king snakes have to have a better adapted way to distinguish the difference between the two snakes in order to be able to eat. And these adaptations will become better over time as they reproduce and they pass on their genes to the next generations of predators. And that is the rest of the assignment.